Now let's expand our division a little bit further. This polynomial divided by 4x squared. Let's write that in a vertical form. So I have 12x to the 8th plus 4x to the 6th minus 8x cubed. I want to divide that by a 4x squared. What that means then is that this 4x squared is going to be divided into each of these terms. So it means that 12x to the 8th divided by a 4x squared. The next term is a positive 4x to the 6th divided by 4x squared. And then I have a negative 8x cubed divided by a 4x squared. So notice that when I'm dividing the entire denominator into the numerator, the entire numerator. So one way to think about it is breaking it on up. From here, we can go ahead and look at each term as its own multiple or its own division. So this first one becomes a negative 3 x to the 8th divided by x squared. I'll just write that. It becomes 3x to the 6th. 4 divided by 4 is a 1, so I'm left with x to the 6th minus 2, which produces x to the 4th. And then subtracting 8 divided by 4 is a 2. X to the 3 minus a 2, which produces a negative 2x to the first. And then let's just kind of clean that up a little bit. Since I kind of wrote both these two thoughts at the same time, I'm left with a negative 3x to the 6th plus x to the 4th minus 2x. Now, this might be a good time to remind us about something. So let's look at a real simplified version of a polynomial divided by a polynomial. Notice that it was the denominator that had to be divided to every term in the numerator. So it would be incorrect of me to just factor out those x's and then I'm left with a 1. That is not correct. This really is an x plus a 1 where each of these terms is divided by an x. So got to keep that straight. We can't factor out when something is part of a summation. Even though we're tempted to do that, we cannot do that. So don't. Got it? Don't.